G'day guys, how's it going? So in this video, we're going to start looking at some methods that exist on the string type and how we can use them to basically look and peek inside what a string is, as well as modify a string. Cool. So let's get straight into it. So what I'm going to do is the first thing I'm going to do is create a string. So we'll go string from, and we'll just say hello world like we normally do. And the first method I want to show you is how we can convert a string into a vector of unsigned 8. So we kind of saw how we can pass in a vector of unsigned 8, but not how to actually get it out. All right, so we can do that by doing the following. We can say let hello world bytes equals some string, and then we can call this method called into bytes. And this returns us a vector of unsigned 8 integers. Cool. We can also do something similar, and we can get an array of unsigned integers as well. So we go hello world bytes. We'll go bytes to equals some string dot as bytes. Now, I believe we did see this in the previous video, but this type is different. So this gives us a reference to an array of unsigned 8. Cool. So if we print both these out, just to prove that it does give you what you are expecting. So we'll just go hello world bytes. And then I'll do the same for hello world bytes too. So if I save that and run, whoops, hang on. I can only do one at a time because of the borrowing. So that's the other thing too. When you call it into bytes, it takes it as an ownership, which means you can't use string anymore. So we have to do one at a time. So let's just start with hello world bytes first. Run that. And now we can see we've got an array of bytecodes, right? And that makes up our hello world string. Cool. Now let's flip it. So that's a vector of unsigned 8s. Now we're going to get a reference to an array of unsigned 8s. So run that. And you get the same result, essentially, right? But one's a vector, the other one is an array. Cool. So that is how you can get the bytes if you need to. The next thing you might want to do is add stuff to a string. So say we have our sum string up here, but I'll change it to say hello for the moment. And we'll make it, mutable, so we can mutate it. So if we want to push an actual extra piece of text into this, we can use the push string method. So we go push string, or str in this case, and we can pass in space and say world with an exclamation mark. Or actually, we'll leave that out for a second. All right. So if I now print this out, and I always forget that exclamation mark here for the macro, run, and we can see we get hello world. Now, if I wanted to add that last character with the exclamation mark, we can also use just the regular push that we've seen with vectors before. So push, but in this case, we have to push a single character. So in that case, it's the exclamation mark. And if I go bang, there you go. Now we get hello world, right? So that is one way we can push stuff into a string. So basically append to the end of the string. Now we can also obviously see the length and capacity, kind of like what we did with vectors. So if I now come back and say, convert this back to hello world, and we'll no longer make it mutable, we can get rid of this. And down here, we'll just print out some string dot length, just like we did with vectors. And there's also a capacity as well. I believe we saw that in the previous video as well, but just to really illustrate it, you can see it's there, right? Cool. So what we can also do is we can actually add extra capacity to a string just the same way we could with vectors. So again, I could come back and mutate this string, and let's say we'll keep the prints there, and then after that, we'll go some string, and then we'll call this method called reserve, and this will attempt to reserve the amount of bytes that we tell it. So let's say in this case, I want to make it, I don't know, 5. All right, we'll say 5, and then we'll print out the same result down the bottom here. Cool. So what this will do is it will reserve extra capacity, but the length will remain the same. So the length is 12, and the capacity is actually 24 here, right? It's not 5 more, because 5 more would be 17. Because the length is 12, 5 more would be 17. So what it's doing is it's saying, okay, you can see it's under what the current length is. I'm just going to add a little bit more anyway, because I'm expecting a potential string of maybe the same length in the future, right? So it adds an extra buffer on top of what you specify. Now, if I set this to 15, then you're going to see it goes to 27. So it takes the 12 and then it adds a little bit more. It's just the way vectors work, right? It adds that extra capacity. We've seen this before. But we can also use reserve exact, like so. If I set this back to 5 and run, well, now it actually is 17. So it's actually reserving only 5 extra bytes. That's where the exact comes in, to ensure that that would be the case. Cool, so that's reserving. Now, let's say we have this and we decide later on, actually, we want to restrict it down to its minimum size, right? So straight after this, we could say something like, I don't know, some string dot, and we'll go shrink 2, and this will shrink it down to the capacity that we want it to be. So if we say something like, let's go 13, right? And then we'll just print it out. Keep in mind that the size of the string up there is 12, right? So if I save this and I run it again, you'll see it goes from 12 to 17 and then 17 down to 13. Right, cool. Now, if I decide to say, actually, I'm going to make this less than the length. So let's say we set it to 7, right? If I set it to 7 here and I run, then it's going to only take it down to the maximum size of or to the length, essentially, of this, right? So it will never go down to 7 because it can't. So it's not going to throw an error. It's not going to truncate the text or anything like that. It's literally just going to shrink the capacity down to as low as it can up to this number. Cool? Now, if you want to make sure that, say it's on 17 and you want to only go back to what the length is, you can also use just shrink to fit. Shrink to fit. And this doesn't take a capacity or a size. So this will ensure that it goes down to 12 regardless. We don't have to specify the actual size that we want. So that's another way of doing that. Cool. So the next thing we can do is we can truncate text. So let's say we've got hello world here, and we want to just maybe keep the first 3 letters, right? So we'll keep the length, we'll keep the capacity. I'll also, just for interest's sake, print out. We'll just do this, right? So I'll add the same line after line 8, and we'll get rid of this last bit. Cool. So now I can use truncate, and this is going to chop out most of the text except for the first, how many letters I put specify here. So if I say 3, like so, and run, well, it's only going to keep the first 3 letters. The length will be 3, but it will keep its capacity at 12. If I change this to say, I don't know, 7, then it's going to keep the first 7 letters. All right, you get it? The first 7 items in the string. Cool. So that's how you can truncate. If you just want to remove individual characters, you can do that as well. You do that a number of ways. So one way is to use the pop that we saw with vectors. So we do something like this. We could go if let sum, and we're going to get a character here. We'll call it C equals sum string dot pop. Now, dot pop. Then we can print out this information, right? And just to be interesting, let's also print out the character. Cool. We run that. You'll see that the exclamation mark is the thing that is popped out. You can see the piece of text without the exclamation mark. You can see that the length is decreased and the capacity remains the same. Cool. So that is one way of removing. Another way we can remove is to just do a method called remove, and that'll allow you to remove a specific index. So I just had to remember off the top of my head what it was called. It was something pretty simple. So we'll get rid of that. So now what we can do is we go sum string dot remove, and we can say we want to remove the letter or character at index 2, right? So that's going to pick up, in this case, the L. Right, so if I now run this, whoops, at the bottom, we can see that one L is missing, and once again, the size has gone down. Cool. So I believe they're the two ways of removing items. We can also look at inserting items. So we've seen push and push string already, but there is also an insert method and an insert string method. So it looks a little something like this. So let's say we have, I don't know, EL world, right? We'll start with EL world like that. And let's then say on this first line, we're just going to insert the first letter at index 0. And we're going to say that needs to be a capital H, right? Now, if I run that, it's going to say, okay, I've added the H to the start of the string. Cool, because you've chosen index 0. We can also add a full string. So we can go dot insert string, and then we can pick where we want to fill in the rest of it. So that would be, say, at index 3, and we're just going to pass in below like that, which should bring it back to hello world. That's the idea. So run that, and now we can see it says hello world again. And you can see as a result that the capacity has been improved, and so has the length accordingly, right? Now we could also, just to make it a little bit easier to understand how the capacity and length is handled, we could just get rid of this and then look at the values on each action. So it starts off with 9, it increases to 18, the extra character is added, but the capacity is added 9, and then it stays 18 once we add the rest of the word, but it increases to 12 length. Cool. So that's inserting. We could fully clear a string, and we could also check to see if a string is empty. Again, this is very similar to what we saw with vectors before. So let's just set this back to what we wanted. Hello world. So we'll keep the first line. We'll keep the second line. So we can do something like sum string dot clear, like so. And before we run it, I'm just going to add a call for is empty, and that's like this. So if you've seen the vectors, you would already know essentially what this is going to do. Basically, it's going to return true if the string is empty, i.e. there's no characters. So the idea here is that when we call clear, this should be true, before it should be false. So run that. And there you go. Hello world, 12 characters in length, false because it's not empty. Now all of a sudden the length is 0. The capacity remains at 12. and is empty is true. Cool. So that's clearing. And the last one we'll look at for this video is split off. So what we can do is we can create a secondary string that comes from the first string by using this split off method. So we can do something like this, where we go let another string equal, I should get rid of that line, some string dot split off. And here we pass in an at or an index, essentially. So say we want to split off the index 5. What that's going to do is it's going to allow some string to keep everything from 0 to 5, which is the word hello. All right, so this will be kept. The rest will be split off and put into this new string here. So some string should say hello, and another string should say space world exclamation mark. Hopefully that makes sense. I'll get rid of the isEmpty calls here. And then I'll just copy this bit here and place it with another string. So you can see how that works. Cool, so we'll run this. And there we go. All right, we got hello world to begin with. We can see it's 12 and 12. Then we've got some strings now just hello with a length of 5 and a capacity of 12. And then the second one, another string, is space world, has a capacity or a length of 7 and also a capacity of 7. Cool. So they're all the methods I want to illustrate for this video. In the next video, we're going to look at string slices, and potentially, if we get time, we'll look at some of the methods that are associated with string that pertain to slices. So I'll see you all in the next video.